Greetings everyone, this is our mini report about topic 6, probability and statistics by group 6.
Problem number 1. Find the probability that a 1, 3, or 5 will be rolled in standard dice. So we know that a dice has 6 faces. So what we did is we have this equation, number of outcomes over the total outcomes. So the number of outcomes is equal to the number of dice faced number will possibly occur. And total outcomes is a total possible combination of dice. So we first solve the total possible combination of dice, or the total outcomes of the dice. So we use the combination formula, or it can also be found on our calculator for a shortcut. So we get 6. So for the number of dice faced number will be possible occur. So it states in the given that it will possibly occur in 1, 3, or 5. So we have three possible outcomes. So we just divide 3 over the total outcomes and we get the answer 0.5.
I am Joshua Ismabini to discuss problem number 2. So, a wheel of fortune is divided into 3 equal parts. Each part is named 1, 2, and 3. What is the chance of landing on a 3 if you know the arrow landed on an odd number? So, to find the probability on landed on a 3, so we need to use this equation. So number of outcomes and the total of outcomes. So the number of outcome used is the landing of 3. So since there are only since the wheel is divided into 3 parts, which is 1, 2, and 3, and since there's only one number that is 3, so we put here 1 and the total number of odd as possible combination. As once again, since there are only 3 in a wheel and the wheel is divided into 3, which is 1, 2, and 3, and the number of odd is only 2, which is 1 and 3. So we put that number in the total number of odd as possible combination. So we have 1 and 2. So the answer is 0.5.
Problem number 3. A mechanical engineering student is taking a 15 items true false type examination. If the student guesses at the answers, find the probability that he gets a perfect score. So in this problem, its requirement is to find the exact probability of student getting the perfect score in 15 items. So solution, the probability that he gets perfect score P is the requirement. So the equation P is equals to T in T to the power 15. So the T is presented as probability of getting one check score per item. So T is just a probability of getting that you get a perfect check per item. Yeah. So probability to get one check per item times probability of choosing nothing over the probability of getting wrong or right. So this is the formula. T, simplify with this. T, the power of 15. So we can see 2 combination of 1 represents that you can only choose 2 choices, true or false, in combination of 1. 1 means he can randomly choose either true or false, so random. So 1 combination of 1 for 1C1 represents that you can choose 1, but he gets the right answer. So that's 1 combination of 1. And then next he can choose nothing about the wrong answer, because it's uh, to complete the equation. So To simplify the hints, means that 1 plus 1 equals 2. Then C, what is it over here? C1, 1 plus 0 equals 1. They must be the same in coin to satisfy. Then to the power 15, so we get 1 combination of 1 is just 1. 1 combination of 0 equals 1. And 2 combination of 1 equals 2. And we simplify. We get the answer 3.051757 times 10 to the power negative 5. As we check in the calculator. So as we see, so this is the formula equation, and we get the answer and fraction and decimal form. Problem number 4. A ball contains 4 blue balls and 6 yellow balls. What is the probability of getting 1 blue ball and 1 yellow ball in 2 consecutive draws from the ball without replacement? So this problem is about probability of getting 1 blue ball and 1 yellow ball. So the order doesn't matter, so it's a combination also. So continue. The solution. So the requirement is that the probability of getting 1 blue ball and yellow ball in 2 consecutive draws for a ball without replacement. P. So P is the requirement. P equals number of outcomes or total of outcomes. So number of combination, 1 blue ball and 1 yellow ball, total possible combination. We're getting 2 balls. Number of combination, blue ball represent this equation for combination of 1 and 1 yellow ball. 6 combination of 1 or 61, and total possible combination getting 2 balls. So 4 plus 6 equals 10. Just 10 and 10 of and 10 balls, you can only choose 2 random balls. So in this problem, its requirement is to get 1 blue ball only. So this there are only in a question, it's represent that there are 4 balls. So 4 in 4 balls, you can only choose 1. So 4C1 or 4 combination of 1 times 6. 6, there are 6 yellow balls. In the problem, 6 yellow balls. So 6 combination of 1, and you get answer. 4 combination of 1 is just 4. 6 combination of 1 is 6. Just 6. And 10 or 4 plus 6 combination of 2 is just 45. And we get the answer. By calculator, scientific calculator. So we get answer this. Getting the combination, just a shift and this divide button. You get the C or combination. So in decimal 0.53. Yeah, same. Okay. Uh, yeah. Next problem. Okay. Answer correct. 0.53. Problem number 5. There are 5 cars in a race. A person chooses 2 of the cars at random and bets one of them. Find the probability that the person picked the winner. Oh, so the requirement is the probability of finding the person that picked the winner. So in the problem, he ensure that he can choose the 2 cars to win as assumption as in the problem as requirement. So P equals number of outcomes over total outcomes. So is 2C1 represents a probability of getting win with 2 bets of car times probability of not betting the remainings. Yeah, because he not bet the remaining three, just only two to to win the uh to win the um car racing. Yeah. So to C1, let's start here. Five. You can only choose five. Possible that in five cars you can choose only two random cars. So that's the combination of five C1 and two C1 as two C2 or two combination of two. Represent that he is 100% sure that he can win using the two tickets or two bets of the car. That's two C2 times the 3C0. So choose the remaining he can because he cannot bet because he only choose two. Three are remaining. So he cannot bet the three remaining cars. Only two. My chances equation configuration 1 2C2 just 1 3C0 is 1 5C2 or 5 combination 2 just 10 0.1 is the answer and we get a calculator. um, so plug in we get the answer. Wait, um, so let's make another one. So two combination 3 combination 0 okay and 5 combination 2 we get answer 1 over 10 0.1 the answer. Okay, correct answers everyone. Correct.
So I am Ashley Lunod and I will report on our problem number six. So for problem number six, a party host gives a door prize to one guest chosen at random. There are 48 men and 42 women at the party. What is the probability that the prize goes to a man? So in this particular problem, we are to determine the probability that the prize goes to a man, and this prize will be given randomly, and the attendants are 48 men and 42 women. So to determine the probability, we can use this formula. So probability is equal to the number of outcomes divided by the total outcomes. So the number of outcomes refers to the total number of men, the prize since the we will be finding the probability that the prize will go to a man, then over the total number of women and men, with that refers to the total outcomes. And in the party, there are 48 men and 42 women. So we have here 48 over 48 plus 42. And the result of that is our probability. So the correct answer is 0.53333 or 0.53.
And thank you.